Division of polynomials. Example 1. Make sure the terms are in descending powers of x, so powers of x going down. Take the leftmost terms and divide them. So 8x cubed divided by 2x. 4x squared. The way we lay out the solution is that the x cubed terms go in this column, x squared terms here, the linear terms here, constants here. So 4x squared will go here. And then multiply the term that we've just written here with 2x plus 1, so with all of this. So 4x squared times 2x, 8x cubed, 4x squared times 1, and then we're going to subtract these terms from these. So these are the same. So when you subtract them, you get 0. Then be careful with the signs. You've got minus 6x squared minus 4x squared. So we've got minus 10x squared. And then we bring one term down from the top. And then once again, take the leftmost terms. So we're working at this stage down here. So the leftmost term here and the leftmost term here, and divide them. So minus 10x squared divided by 2x minus 5x. The result will go up here. The x terms line up in this column, so minus 5x. And then you take the minus 5x and only the minus 5x and multiply it with the 2x plus 1 here. So just this term multiplied by all of this. So multiplying these two will give minus 10x squared, multiplying minus 5x with 1, minus 5x. Subtracting again. So minus 10x squared, minus minus gives you a plus, so these will cancel. And x minus minus 5x, so x plus 5x, 6x. Then we take another term down. So we're now working at this stage. Take the leftmost term here, the leftmost term here, and divide. 6x divided by 2x. Put the 3 up here. We've got all the constants lining up here. Now take the 3 and only the 3 and multiply it with 2x plus 1. And then subtract again. No more terms to bring down, so we have our solution here. Now the numerator here is called the dividend, and we're dividing by what we call the divisor, like this. Up here we have the quotient, down here we have the remainder. A useful form to write all of this in is like this. So the dividend is this, the divisor here, the quotient from here, the remainder from here, and the divisor here. a quick application for something like this could be, let's say if we're trying to integrate this function here, instead of integrating this, we've simplified it to these terms here, so we integrate these terms instead of integrating this. Example 2. This time our polynomial here is missing an x squared term. So if you look at the solution, you'll see that I've left a space here for the x squared term, so that I'm still able to write all my x squared terms in this column. And then the final solution can be written in this form. Example 3. This time we're dividing by a quadratic polynomial. So we get the following solution. Which can be written in this form. Example 4. Again, we're dividing by a quadratic polynomial. Here is the solution. The remainder is 0, which means our divisor here is a factor of this dividend of this polynomial. So in this form, we have the quotient here, but there was no remainder. The remainder was 0. And 0 divided by the divisor, or 0 divided by anything, is 0. So there's nothing here. Example 5. Slightly different this time. We have some unknown terms here. The a is unknown here, the b, the c. Here's the polynomial. It's divided by the divisor here. So this is the dividend, the divisor, the quotient is given, and the remainder is given. So we can write these in this form, like so. So to work out a, b, and c, if we multiply by x squared plus 2x minus 1 here, here, and here to get rid of the fractions, we now have this. To expand the terms here, I'm using this grid method. So multiplying the terms here, this is just a multiplication grid. We got x to the power 4 term here, x cubed terms, x squared terms, x terms, and the constant. So the x to the power 4 term is here. You got 2 plus b for the x cubed terms. There's a minus 1, there's a 2, and there's a 2. Or, well, a minus 1, a 2b, and a 2. And for the x terms, there's a minus b and a 4. This c is coming from here. And the constants, well, we've got a minus 2 here, there's a 7 up there, that gives 5. So all of this expanded and simplified, like terms collected, will give these terms. Now we can compare the coefficients of the x to the power 4 term, the x cubed term, and so on, with this polynomial with this. So the x to the power of 4 terms are not telling us much. Looking at the x cubed terms, we know that 2 plus b should be equal to minus 2. Looking at the x squared term, 1 plus 2b should be equal to minus 7. Looking at the x terms, 4 minus b plus c should be equal to 7, and we know that a should be equal to 5. So we can work out our values of a, b, and c.